we present a protocol to investigate the effect of aggregate surface morphology on the formation of interfacial transition zone in cement-based materials. It combines the experimental method with data processing method to illustrate the effect of aggregate surface roughness on ITZ formation.
Begin by molding the model concrete. Weigh 1,000 grams of cement and 350 grams of water with an electronic balance, and wipe the 5-liter mixing pot with a wet towel to moisten it. Add the water and cement to the pot, place it on the mixer, and raise it to the stirring position. Mix at 65 RPM for 90 seconds and let the mixture sit still for 30 seconds, scraping the paste off the inner wall of the pot. Then mix at 130 RPM for another 60 seconds. Remove the pot from the mixer and put the ceramic particle into the paste. Then thoroughly mix it with the cement paste by hand. Half fill the mold with the fresh cement paste, place the ceramic particle on top of the paste, and fill the rest of the mold with the paste. Wipe off excess cement paste with a scraper knife and vibrate the mold on a vibrating table for 1 minute. Seal the mold surface with cling film to prevent moisture evaporation. Cure the specimen in a curing room for 24 hours. Then remove the specimen from the mold and cure for 28 days under the same environmental conditions.